Okay, this video summarizes the results that were found in the previous derivation. So if you didn't want to listen to the derivation, that's fine. You can get the results of what you need here. These results only apply if the acceleration of the object is constant. If it's ever, not just for free fall. Some students think these equations are only good for free fall. That's not true. They're good for anything as long as the acceleration is constant. In this case, I'm calling P the position because your book sometimes uses X for position, sometimes it's Y for position, depending on whether it's horizontal or vertical. If they're talking about angles, they'll use theta for a position. So to avoid confusion, I'm trying to use P. So whatever the variable is, P is the position variable. So you can just replace that with X or Y or theta or whatever the variable happens to be. In this case, V is going to be the velocity. It's really speed because we're talking about the motion in one direction here. So you know which way it's headed, and so really velocity is ultimately just the speed. Okay, so here are the formulas that came from the derivation. Position equals initial position plus initial velocity time times initial time. This is the constant acceleration. If it's a negative acceleration, you just have a negative number right there. In this case, this equation differs from your book because your book assumes that everything, the PO and the VO, all of those things occur when time equals 0. In this particular case, this equation is good even if the initial position and the initial velocity are occurring at some other time. This is useful when you're solving problems where they'll say one object, a ball, you threw up at time equals 0, and you wait 2 seconds, and then you throw the second ball. So if you're waiting 2 seconds, in that case, the TO would be 2, and so you put a 2 in there when you're solving that particular ball. Same thing with the velocity. So TO is the same thing. VO is the initial, original velocity, however you want to think of it. I think your book writes this equation as V squared equals V0 squared plus 2a x minus x, or I think s maybe. But anyway, so it's the same thing. But I kind of like to look at it like this. It's up to you, but they're exactly the same thing. Okay, the other conclusion is, what do you know about things that are in free fall? So here you go. If an object is flying through the air, right? If you throw it or whatever, and there's no wind, then it has an acceleration of 0 in the horizontal directions because nothing is trying to speed it up or slow it down. And it will have an acceleration of g downward towards the earth. So whenever it's throwing through the air and nothing is touching it, that's the case of the accelerations. So you're going to use that in solving some of the problems.